Assalamu alaikum everybody. Welcome back to my channel. Raise your hand if you ever spent 20 minutes starting at a reaction only to pick the wrong mechanism. Yeah, me too. But today you will learn the one flowchart that solves SN1, SN2, E1 and E2 reaction in seconds. No more guessing guys. So you can determine whether the reaction is SN1, SN2, E1 or E2. Quickly ask these three questions to identify the mechanism instantly. First of all, is the substrate primary, secondary, or tertiary? If the substrate is primary, then it would be SN2 or E2 mechanism. If it is tertiary, then it would be SN1 or E1 mechanism. And if the substrate is secondary, then we have to check out other factors, that is a strong base or good leaving group. Second question you have to ask is the nucleophile or the base is strong or weak? If it is strong, for example, it is having hydroxyl group or RO group, then it would be SN2 or E2 mechanism. And if it is weak, then it would be SN1 or E1 mechanism. The third question is about the solvent. That is the solvent is polar protic or aprotic. If it is polar protic, then it favors SN1 or E1 mechanism. And if it is polar aprotic solvent, then it would favor SN2 or E2 mechanism. So students, let us start with SN2 hack. Follow the mechanism given in the picture along with the description. So attack would be from backside. That is nucleophile hit and the leaving group leave in the opposite directions. Therefore, inversion will take place. And it will be fast for the primary carbocation, then secondary carbocation. As tertiary carbocation is too crowded for SN2, so it will not take place for tertiary carbocation. And the leaving group must be a good leaving group. That is, for example, bromine, iodine, etc. Tip to remember SN2 reaction: substitution nucleophilic second order, that is, it will be bimolecular. For SN2, it is a two-step mechanism, that is, leaving group leaves and the carbocation forms, which will be the rate determining step. Nucleophile attacks and the rate determining step will be the slowest step, and it is fast for the tertiary carbocation, then the secondary carbocation, and the primary carbocation will not undergo SN1 reaction. Racemization will take place, carbocation will be planar, and the attack is possible from the both sides. And tip to remember SN1, that is substitution nucleophilic first order, that is, it is unimolecular. Now students, let us discuss the E2 hack. It is a one-step mechanism. Now we will spot the requirements for E2 mechanism. The first requirement is the strong base. Second requirement is the good leaving group. And the third one is the availability of beta hydrogen. Its symmetry should be anti-periplanar, which means that it must be in the same plane, usually in the 180 degree. The quick hack is, if the weak bases are present, it would favor more substituted alkane according to Setsev rule. Requirement for the E1 are substrate would be tertiary, as a tertiary carbocation undergo E1 mechanism because it is most stable. Leaving group must be good. It would be bromine, iodine, etc. Base will be weak, non-bulky, and the solvent will be polar protic solvent. For example, water, or alcohol because these solvent stabilizes the carbocation. Now on the screen you are watching a quick comparison table of all the mechanisms we have discussed so far. Pause the video, note it down in your notebooks. It will be really helpful while you are practicing and revising all these mechanisms. These pro tips will be really helpful to you in memorizing all these mechanisms. SN1 and E1 are considered as the siblings. SN2 and E2 are rivals, that is, they are opposite to each other. If heat is used in the reaction, it will favor elimination over substitution. These are the practice questions for you. And if you want a printable flowchart, comment flowchart below. Like and subscribe. Thank you for watching.